Broadcasting live. It's America's longest running talk show on computers. It's Computer America, bringing you the biggest names in technology with guest interviews, new products, and your emails. Listen live at computeramerica.com on any device around the world. Email the show at live@computeramerica.com or find us on social media. Be sure to check out our website for contests, giveaways, show notes, live video stream, podcasts, and more. You're listening to Computer America.
Hello and welcome everyone into the Computer America Show. We are the nation's longest running nationally syndicated radio talk show on computers and technology turned podcast. Everyone, welcome into the program. I hope that you're doing well and you forgive my voice getting over the last bit of the plague and that I picked up from my childhood arcade, which, always a lot of fun to go back and revisit, but at the same time, man, I feel kind of bad for kids nowadays, just, and obviously that's just one individual establishment. A lot of the arcade games and arcade cabinets and a lot of the fun stuff has been replaced with literally gambling. But I think that's just kind of what makes those places profitable. Good news is they put in a bowling alley. So, hey, all things in balance. So with that being said, everyone, welcome into Computer America. I hope that you're doing well and better than me, and you are ready for today's program. Because today on the show, we have, you guessed it, Ralph Bond. He joins us every single Friday, and he is our science and tech trends correspondent. And if you're curious what that means, well, hey, he's going to tell you. So before we get started with that, computeramerica.com, that's where you'll find everything, including past shows, future shows, show notes, articles, everything that we do here on Computer America, you can find on our website. And there you will find, especially the show notes, I want to highlight that. At the top, we have a whole segment dedicated to Ralph Bond, and in that, every show that he does, he comes up with this amazing list of, sources, links, stories, anything that you need to know. It's going to be right there under today's show. So if you're driving, if you're like, I do want to find out more about that, because we definitely encourage that with segments such as these, it's going to be right there under the show. So again, computeramerica.com for all of that good stuff. Let's go ahead and just bring Ralph on and have fun with it. So once again, science and tech trends and everything that comes with, science and technology. Ralph Bond, welcome back onto the program. How you been?
I'm doing okay, and I hope you feel better real soon. I'll tell you, this stuff's going around all over the nation. These
Absolutely.
colds and sore throats and all that kind of good stuff. But anyway, for people who are new to the show, welcome, of course. And let's explain what Ben and I do every Friday. What we do is we highlight 4 articles that show us key trends and developments in everything: artificial intelligence, robotics, medical technology, sustainable energy technology, transportation advances, agricultural tech, construction technology, space research, physics, on and on and on, you name it. But most important of all, this is really key, we're going to give you hope for a better future, thanks to the amazing breakthroughs happening every day in the world of science and technology.
Absolutely, and really emphasize that in the world, because these stories can come from really anywhere, and often kind of come from everywhere all at once. These partnerships that you always highlight include, places from China to Norway to the US to South America, so on and so forth. Science really does seem to bridge a lot of those, divides. So with that being said, story number 1 is where we will start, and we're going to talk about, you may know microwaves as the thing that brings you Hot Pockets. Well, how about this? Maybe your next computer, or at least your CPU for your computer. So, Ralph.
Yes. Well, this first story comes from LiveScience.com. Headline: this is really interesting stuff. And you know what, Ben? Before I even read the headline, it just still amazes me that the general news environment just doesn't pick up on some of these things that are so profound and so important, potentially at least. Anyway, but headline: scientists create world's first microwave-powered computer chip. Subhead: it's much faster and consumes less power than conventional CPUs. So in the world of chips, if you will, you have your traditional chips, then you have your chips that require extreme low temperatures to operate in the world of quantum mechanics and quantum computing and all that sort of stuff. Now we've got to throw into the mix microwave powered computer chips. Pretty interesting stuff.
Yeah, and even more timely given that, a lot of the news that came out this week when it came to technology was, NVIDIA and the demand that they're seeing for their chips and everything. And Ralph, what goes along with that is the demand for energy, for power, for electricity.
Oh, boy.
Actually, I do, I told you before the show, I wasn't really tuned into the news, but I did read that, I think it was like Microsoft or someone gave a grant, and like the U.S. Department of Energy, kind of backed it as well, that like 3 Mile Island, like the nuclear power plant, is going to be rebooted. And I was like, wow, what is old is new again. And it really goes to show just the demand for energy that we're seeing in technology. So stories like this, all the more relevant.
Absolutely correct. But going on to this story about microwave chips, here we go. Scientists at Cornell University have developed an entirely new kind of microchip that uses microwaves instead of conventional digital circuitry to perform operations. And I'll stop right now and say to the audience, hey, folks, this is very geeky stuff. In the full research papers and articles and so forth, there's much, much more detail than what Ben and I are going to give you here. What we do with the 4 stories we highlight each Friday is just give you super condensed highlights. So it's important, as Ben said, to come out to computeramerica.com, get the show notes. We'll have links, pictures, and so forth if you want to dive deeper on any of the stories. But with that said, let's go on here. The new processor is the world's first artificial intelligence, of course, based microwave neural network processor that uses microwave physics to perform neural network computations. We'll say a little more about neural networking here in a minute. High bandwidth applications such as radar imaging demand high speed processing. Microwave neural network chips, for example, like the one that the folks here have created, can process radar signals in real time, enabling precise tracking of moving objects such as aircraft, vehicles, or drones. And tracking drones these days, folks, ding, 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 pretty important. Just go to Ukraine and you'll find out why. Anyway, microwaves that operate in the analog spectrum can meet the processing needs of these kinds of applications, which is why scientists have pursued this new approach to computing. Pretty amazing. So instead of executing instructions sequentially, get this, Ben, instead of executing instructions sequentially, like a digital processor that we all know and love, it performs parallel, real-time, frequency domain computations. Now, that's a mouthful of geekiness there, folks. Again, the research papers and the links that I have in the show notes will help you understand this more if you want to dig into that.
Yeah, I don't know many people who, would know off the top of their head what frequency domain computation is, but yeah.
Yes. I think, friends, and this is where I step on the plank, I'm almost going to jump into the water of stupidity here for a second, but I think it has to do with dealing with the frequency of the microwave as a way to do calculations or computations as opposed to the binary on-off bit business that we're so familiar with in traditional computing. But anyway, going on, neural networks, which underpin the microwave chip they've developed, are collections of machine learning algorithms that are inspired by the structure of the human brain. A neural network, and this is key, learns patterns from data and uses them to make decisions or predictions. So there's a little tutorial aside on neural networking. And to wrap things up here, and again, this is very, very condensed. Come to the show notes if you want to learn more. Wrap it up here by operating in the microwave analog range and applying a probabilistic approach. That's the predictive business. The chip can process data streams on the order of tens of gigahertz. So once again, just giving you very, very high level highlights here. So much more to learn about this amazing microwave chip technology.
So maybe not your next computer at home, but but maybe has very niche applications, which we've seen a lot of research. Ralph is like, not everything that these researchers are going to do is going to just be the next best thing for the consumer or the end user. But hey, maybe for something, just a couple of weeks ago, we did a story about I think it was like a way to like power low level electronics, and it was extremely low power, but maybe for space exploration, maybe for little
There you go.
sensors in
Yeah.
remote forests and stuff, stuff like that. It makes a difference.
Yeah, it absolutely does. And if you look at this breakthrough, this microwave chip, if you will, you're talking about low power, which is very important, parallel processing, the ability to do good predictive stuff and to support neural networks. These are the things that we usually talk about when we're talking about quantum computing and that sort of thing. Here we have this entirely different way of going that doesn't require having sub-zero, super cold environments like they do for quantum computing. It could be, we'll see, it could be a very, very important technology, as you point out correctly, for specific applications such as the radar business we mentioned in the story here. Now, we'll
Absolutely.
see.
Yeah, absolutely. So with we'll let them focus on that for another 5 to 10 years. We're going to move on to story number 2, where we're going to talk about, light-emitting materials. And, the pictures are going to be, I'm not going to say they're going to knock your socks off, but I think the implications behind what the images are is going to be very interesting to you. So, Ralph, story number 2.
Yes, and a good example of early research, as you point out, in a way. And I've just a little bit of a warning here. This news deals with some very geeky stuff, which I don't pretend to understand fully, but we'll try to give you the highlights because it is an interesting development. So the headline here from TechXplore.com, headline, Green Alternative for Light-Emitting Materials in Displays Uses Plant Waste and Amino Acids. Ben and I we just love these stories, and we've reported on it over the past several years, where you take natural things to make stuff that we usually associate with metals and petrochemicals. And no, this is a really, really interesting way to have a display technology that's based on plant waste and amino acids. Okay. So let's get into the story. Photoluminescent materials are essential for modern technologies such as displays, diagnostics, solar cells, and optoelectronic devices and sensors. Okay. Traditional photoluminescent solid-state materials used in TVs, smartphones, sensors, biomedical imaging, you name it, often rely on toxic metals, non-renewable resources, and wasteful multi-step production processes. So there's the issue at hand. So here we come. Here, enter Yale University scientists have devised a way to create a green alternative to these traditional light-emitting materials. Wow, good for Yale. The University Center for Green Chemistry and Green Engineering. Don't you love that? Center for Green Chemistry and Green Engineering. And in combination with Nottingham Trent University in the UK and the University of Hong Kong. I love collaborations, as you know. This is a great one. Well, this team developed a process that combines lignin. You may remember that if you've been a long-time listener of the show. We've talked about lignin before, which is a plant-based byproduct of wood paper industry production, with histidine, a simple amino acid. Now, again, this is geeky stuff. We've talked about this before. Lignin is a complex organic polymer found in the cell walls of plants, especially wood and bark, where it provides rigidity, strength, and resistance to decay. It is one of the most abundant natural polymers on Earth, second only to cellulose. So it's not a rare
cellulose gets all
mineral.
the attention, and then lignin kind of falls by the wayside.
Yeah, and the recipe, the ingredient formula here does not involve rare earth materials or any of that kind of stuff. This is one of the most abundant natural polymers on Earth. So the result produced solid-state materials that fluoresce under UV light with tunable properties using only green solvents, water, and acetone. Acetone scares the heck out of me, but nonetheless, that's what they're working with here. And let's drill down again. It gets geeky, very geeky. How does this work? Well, phenolic, Phenolic, phenolic groups of lignin absorb UV light and become energized. And these phenolic groups are ordinary alcohols. I have more detail in the show notes if you want to get into this. But here's the deal. They transfer protons to histidine via a process called, this is mind-bendingly geeky, excited state proton transfer.
I think I've read about
Okay.
that in a comic book once. Yeah.
Yes, that does sound like a Superman thing. So excited state proton transfer is a photophysical process where a proton moves within or between molecules after the molecule absorbs light and enters an excited electronic state. I have excited electronic states, but not in this category. So again, friends, I apologize. Very, very geeky stuff, but it is interesting. As lignin relaxes, it emits visible light at room temperature. Very important, the room temperature part. And some materials even glow briefly after UV light is switched off. So let's wrap this up with a quick summary. This Yale research demonstrates sustainable chemistry by using abundant plant waste streams. Lignin is a byproduct of processing wood products, by the way. So this process avoids reliance on toxic metals, as we mentioned at the outset, simplifies synthesis while reducing hazardous chemical waste, and computational modeling confirmed how lignin and histidine interactions enable efficient light emission without metals. Wow.
So all of the story, and of course there's a lot more, and the picture, again, may seem a little, a little underwhelming, but it shows that, hey, you can at least have some sort of display without metal. And that seems to be really, the heart of it. And I guess the other, fun little tidbit that we can pull away from this is that there is a Center for Green Chemistry and Green Engineering. So not just not just a little discipline within these, but entire, I guess, at Yale, entire places that are just devoted to green engineering, which, I did not know before.
I know, but I thought that was just so amazing. Can you imagine what it must be like to walk the halls of that place? I mean, wow.
Absolutely. So yeah, it's still great research. And once again, maybe something that, in a very unique setting, odds are you're probably not going to have a monitor made of this stuff, but hey, this could be something that, Ralph, maybe in like highly magnetized places that you can't have metals traditionally. Hey, maybe this would be something that we could do. So very cool. And ladies and gentlemen, as always, if you want to find out more, Computer America, show notes, and trust me, there is more to that story. I promise.
Yeah.
So story number 2, story number 3, we're going to go ahead and jump on down, and we're going to, talk about something that is like Kevlar. And, if you don't know this about Kevlar, there's room for improvement. I believe Kevlar is like a one-time use thing only. Once it's taken a bullet, it's not, unlike the movies, it's not good forever. You can't just take like 30 bullets. No, it's one-time use. It's very difficult to manufacture, very heavy. It's something that could be improved in a lot of ways, and it saves a lot of lives. It's bulletproofing is very important. Well, story number 3 is, something that hopefully also can save many lives, and let's find out more about it. So, Ralph.
Yeah, this one's really cool. This is from Popular Mechanics, and the headline here is scientists created a bulletproof material 3 times stronger than Kevlar, and it's already breaking records, is what the subhead says. Wow, really cool. And in the show notes, we have the image from the article, or actually from, I think, the research paper. And it shows 2 of the researchers holding up this, it looks like a bed sheet or something of this new Kevlar-like material. It's so interesting, and it blows my mind.
And it seemed to the point where, like in terms of thickness, I don't really know, if you can see through Kevlar, but this one, you can see like the silhouettes of the people behind them.
It's
so
amazing.
This material is see-through and bulletproof at the same time.
Right. And I'll digress a little bit here before we jump into the story. That probably what happens is to make, say, like a Kevlar-like vest out of this material, is probably layers of this material.
True.
As opposed to just being super thin. But nonetheless, it's still pretty interesting the way they're just holding up this big, looks like a giant bed sheet or a tarp or whatever. Yeah. Okay, so into the story here. Since its invention in the 1960s, Kevlar has saved thousands of lives, as Ben mentioned earlier, especially police officers, due to its lightweight yet strong properties. Lightweight, relatively speaking, considering this new breakthrough. Scientists at the University of Peking in China, of course, have developed a new material that is 3 times stronger than Kevlar and only 1.8 millimeters thick. Now, I inserted into the show notes something I thought to myself, well, that's cool, but I need to compare this. So a little side note, to appreciate this achievement, consider this. Today's standard police Kevlar vest is typically 6 to 12 millimeters thick. That's about 1/4 to 1/2 inch thick and weighs approximately 5 to 7 pounds. So the police officers you see today are walking around with something that weighs anywhere from 5 to 7 pounds. That's significant. And using the new, stronger and thinner material from the University of Peking, you could make an officer's vest weighing only 2 to 3 pounds. Kind of like cutting it in half, kind of, sort of, right?
Yeah, it
Wow.
certainly makes a difference. And not only that, I'm sure with the reduced weight, you could even do different form factors. You could do things like
Good point.
arm guards, and you could do, like sleeves, essentially. You could do pants and whatnot. That traditional Kevlar, it would be very cumbersome to do that.
That's an excellent point. It really is. And the material, how did they do it? The material combines carbon nanotubes with aramid polymers, the same type used in Kevlar, meaning the aramid polymers. So they've combined something that existed in Kevlar's recipe with this new factor of carbon nanotubes. Now, aligning the carbon nanotubes with the aramid polymers prevents slippage under extreme impact, like a bullet, giving the fabric ultra-high dynamic strength and toughness. And of course, beyond vests, potential uses, as the article points out, include bulletproof armor, vehicles, and aircraft. Skinning the aircraft with this material? Interesting thought. I'm thinking about helicopters too, which often get shot with drones and rockets and so forth and so on. So pretty cool stuff.
For sure. I was also thinking, I don't think Kevlar is used, but it's more like carbon nanofiber that's used for, like racing boats and racing cars, and that give it that kind of a little bit of flexibility, a lot of toughness, and are super light. Yeah, Ralph, like this could totally see an application in, high performance vehicles and, just for the fun parts of vehicles, not even just so much the combat part.
Right.
So yeah, very, very cool. And again, you can see an image of it right there. So love to see more of that come to more places. So story number 3, story number 4. We're going to go ahead and wrap up today's show because we try to keep the show a bit more condensed. We limit it to about 4 stories. And the 4th story, Ralph's going to tell you about, but spoiler alert, it's going to be medical news. So Ralph.
Yes. Our last story usually is medical technology and science related because that's something very near and dear to my heart. And the headline here from MIT Media Lab, this is from their post, Injectable antenna could safely power deep tissue medical implants. And the subhead here, the technology would allow battery-free, minimally invasive, scalable bioelectronic implants such as pacemakers, neuromodulators, and body process monitors. Wow, that's a mouthful, but it's very cool. So again, good old MIT. So researchers from the MIT Media Lab have developed an antenna about the size of a fine grain of sand. What? That can be injected into the body to wirelessly power deep tissue medical implants such as pacemakers in cardiac patients and neuromodulators in people suffering from epilepsy or Parkinson's disease.
It wasn't even like really that long ago, and since like we got these microchips for pets, and like if you lose the vet can kind of scan it, and they said, Ralph, that it's kind of the same size, the size of a grain of rice, and you can scan it and it'll pick up and kind of tell you who owns the pet. In just like a short, like 10, 15, 20 years, we've come to the point where, the same size of technology can actively monitor and send real-time information. That's crazy.
It's pretty great. It's very cool. So going on here with the story, deep tissue implants are currently powered either with a several centimeters long battery that is surgically implanted in the body, requiring periodic replacement, or with a surgically placed magnetic coil, also of a centimeter scale size that can harvest power wirelessly. So that it's sort of like the way your phone gets charged when you just put it in the cradle. You're not actually connecting a cable, that kind of thing. The coil method functions only at high frequencies, which can cause tissue heating, limiting how much power can be safely delivered to the implant when miniaturized to sub-millimeter sizes. What we're doing is setting the stage for what the challenge and problem is and how this MIT technology addresses this. That's what we're doing here in the article. The MIT 200 micrometer antenna operates at low frequencies, 109 kilohertz, thanks to a novel technology in which magnetostrictive film, which deforms when a magnetic field is applied, is laminated with piezoelectric film, which converts deformation to electrical charge. There's a mouthful of geekiness going on in that paragraph, and you need to dig into the research paper and other information to learn more about what's going on.
For sure, and it seems like they've combined 3 or 4 different piezoelectric, magnetostrictive. A lot of big words, but it seems like they're just finding a way to power this. And I know I've heard of piezoelectric before. In our stories before, right. But I have not heard of magnetostrictive film. So that's
isn't that something? Yeah, and piezoelectric means when something moves, it generates energy, generates electricity. So that's what that is. And to put this bit about 200 micrometer antenna, to put the size into perspective, a micrometer is a unit of length equal to 1 millionth of a meter. So we're talking about 200 millionths of a meter. It is teeny tiny.
Just incredible that they're able to shrink it down and still make a useful piece of technology. So let's see what it can do.
Mind-blowing. So when an alternating magnetic field is applied, the magnetic domains within the magnetostrictive film contort in the same way that a piece of fabric interwoven with pieces of metal would contort if subjected to a strong magnet. This mechanical strain in the magnetostrictive layer causes the piezoelectric layer to generate electricity charges across electrodes placed above and below. Wow. And because the antenna is fabricated with the same technology as a microchip, it can be easily integrated with already existing microelectronics. This story just gets better and better. And manufacture of the antennas could be easily scaled up, the MIT researchers say, and multiple antennas and implants could be injected to treat large areas of the body. Okay, MIT, once again, congratulations. Amazing.
I'm curious. So it sounds like, you do that alternating current, it kind of flexes this layer, and then it moves a piezoelectric battery, which gives it a charge. I say all that like I understand. I'm sure I don't at some level, Ralph. I'm just kind of curious. I wonder if you can feel it like wiggle if it's implanted in your body. Like it's only 200 millimeters, 200 micrometers. Very, very tiny. I wonder though if you could feel it wiggle or if it's just going to be too subtle. I don't know.
Yeah, that's a good question. It's this in the world of medical technology and science and implants, Ben, you and I have seen time and time and time again, extreme miniaturization, the idea of being able to inject something into you instead of surgically implant. It is such a key trend. We're about trends, right? That's key premise of our Friday shows. A lot of times it's early technology, early research, trends. Watch this trend. It's on fire all over the world, and you're going to see more and more and more of this miniaturized stuff that you can inject into the body instead of surgically opening someone up to implant something. It's very, very cool.
Absolutely. And yeah, it's certainly an area that is advancing very, very fast, along with, really almost everything that's science and technology. I think, advances in so many fields, but I don't want to say it's all AI, but AI has really led to, increases in a lot of its research and the speed at which the research is coming out. So, not so much this one. They didn't mention AI anywhere in there. I'm sure it does. But anyways, so story number 4, story number 5 doesn't exist. That's because, if you may notice, as you go down, there's a 5th story. And in fact, there are 4 more stories, if I am to be assuming correctly. There are multiple stories. below the stories that we just did. And again, to kind of keep things more concise, we are going to go ahead and just mention the honorable mentions. And these are stories that are perfectly great. Ralph still went through all the trouble of getting the show notes out of them, links to all of them. If you want to find out more, come out to Computer America. You can see the stories there, follow the links, and do some late reading yourself and find out about these amazing stories, because they're just as good. They're not worse. It's just we don't have time. So Ralph, if you would, let's at least give them the headlines so they can come out to computeramerica.com and find them themselves.
Yeah, this is fun stuff. This first one comes from phys.org, short for physics.org. Headline, Tabletop Particle Accelerator could transform medicine and materials science. Tabletop Particle Accelerator? What? Check it out, folks. We got the links.
Well, yeah, because, the last particle accelerator that we heard about was CERN, and that was only about 13 miles long. So to go from 13 miles to Tabletop.
Just like what? I know, crazy. It's almost hard to believe. Check it out. It's pretty cool stuff. Next one comes from Columbia University Engineering Department. Headline, need a new 3D material? Build it with DNA? Wow. Okay. Pretty geeky stuff. Pretty interesting. Gotta love that. Okay, next one. From 3dprinting.com. That's a cool outlet, by the way. Headline, spider-like robot combines 3D printing and construction for Earth and lunar applications. A construction robot. This one's really fun to look at. I mean, look at this thing. If we are looking at the show notes and watching this on YouTube, you can see what we're talking about. It's very, very cool stuff. So that one's fun to check out. And by the way, construction technology is the last thing to be considered boring, along with agricultural technology, both very, very exciting fields. The last one for today, TechXplore.com is the source. Headline, robots you can wear like clothes. Automatic weaving of a fabric muscle brings commercialization closer. This is just an astonishing story, and you really encourage everyone to come out and check this one out. This has profound implications for prosthetics.
Yeah, in fact, that one, and we're going to go ahead and start the outro music there, which you can hear in the background means we're going to wrap up. I will just say about that last honorable mention, if it seems like something that, wouldn't really do all that much, well, like Ralph said, between prosthetics, between repetitive factory work, between military and search and rescue and walking and hiking and just really anything, it's going to have really cool implications. So hey, in fact, I can say that about all of the stories. So if you want to find out more, computeramerica.com, you'll see this entire show notes right there posted on our site. And of course, wherever you hear podcasts, up on YouTube, ladies and gentlemen, you can find Computer America on all of those and social media at Computer America on all of those as well. So Ralph, I want to thank you so much. This has been an amazing show, amazing stories as always. Hopefully everyone out there feels better, uplifted, and ready to tackle the weekend. Ladies and gentlemen, we'll be back next week, and everyone have a great Thanksgiving, because you will have Thanksgiving by the time that you hear our next program. Have a great Thanksgiving. Do something fun. Catch you next time. Bye, everyone.